All right, welcome back MIS. Another installment of SQL 101. All right, what I want to do here is really just introduce aggregation. All right, queries with aggregation. This is what you need to do for homework 8 for your next kind of installment in learning how to do SQL queries and stuff. All right, so let's get to it. All right, first, just not a recap, but just to remind you, okay, last time in the last video, you can check this out, we did stuff called computed values, okay, so sometimes you need to display stuff in a query that's not actually stored in the database somewhere, all right, and for this what you do is you need to compute the actual values in some way, okay. So what I want to do here is kind of recap that a little bit with a new database here. This is a more common kind of your standard sort of retail. I tend to think about like web retail. Amazon is a great kind of example for this kind of database. Okay, and so we just want to break this down and go through a few differences between computed values and aggregation, and just give you a few examples of different aggregation kind of queries that come up rather often. All right, hopefully it'll be helpful in your homework. I can tell you that it's definitely helpful for the exam. All right, so let's do this. So first off, as always, right, new database, go to the relationships, open it up, and check out what's going on here. Okay, so what we can see here, we have 4 tables. All right, and all we're doing with this is customers are essentially being related to products via orders. All right, customers meet with products via orders. That's what's going on here. Okay, think Amazon. Right, there's another table, call it order details. Here, sometimes you see it as product orders, different things. Right, it really just reflects the fact that in any given order, right, more than one product could be ordered. Right, and obviously for any one product, that's going to appear in many orders over time. Okay, i.e. these are in a many to many, and this is the one between. Okay, so I'll keep this up throughout to help us out here, and let's get started. All right, so let's go make a new query. Okay, first what I want to touch on is going back to computed values a little bit. All right, so let's get this to a decent size. So computed values, right? Let's consider first just some real basics, like let's say we want to, all we want to do is see the tax adjusted price, so the total price of any given order, of all orders, the total price of all products with tax. Okay, how would you do something like that? Well, if we look at the products table, right, we have this stuff, there's a unit price here, and let's make an assumption, right? So first, products, so let's just do p dot product name. All right, we just want to see the product names along with the unit price. Okay. From products is p. All right, throw in that modifier, and let's also order this by the unit price. Yeah. All right, end with a semicolon. See what we get. All right, looks like that worked. All right, cool. So, right, again, that's the actual unit price, okay? And you can check and see that that's definitely what we see here. We threw no conditions, so that's simple enough. If we want to see it with tax, let's say we make an assumption that there's, say, an 8% sales tax, all right, or 8% tax in general, right? 1.08 times this, okay? And let's do that as total, I don't know, with tax. Whoops. Run that, and we get this. Total with tax. Okay, cool. Right, you can see that these went up a little bit, so the prices have changed. Okay? And again, we could format this if we wanted to, but let's try to stay focused. All right? So what's the difference here? Or what just happened? What makes this a computed value? All right, what's the difference between this and aggregation? Okay, this is kind of the simplest case because you can see that in the products table, for every product that you have here, all right, you can simply go through row by row, right, and in any given row, like this one, you can take the one unit price that's there and you can multiply it by 1.08, and you can stick that value in along with the 17-inch VGA monitor, and you get that in this query, right? So that's why this looks the way it does, right? Here's what we were just saying, right? We get that tax-adjusted price. Okay, that's a computed value, all right? That's one example of a computed value. Okay, there are others, though, and I'm going to highlight the difference here, right? The reason, again, that we could do this was because we only need the information available in this one row in order to be able to compute the thing we need, okay? That's what makes it a computed value and not an aggregate function in some sense, right? But what are some other examples here? Okay, let's work through another one, like taking a look at the total gross value of product inventory, all right? So just thinking about the inventory as what we have, right? So let's say inventory being the number of units in stock, okay? And look at the total value of that, all right? What would that be? What would that be? Well, that would be the total, the unit price times that number, right? P dot units in stock, right? So the units in stock times the unit price of, each one, all right? And that'll give us something inventory value, right? Right. And let's order it by that, okay? And again, so we can't use that. We have to use the whole thing. Can't use the modifier. So we order this in here, and let's do it descending so we can see the biggest ones. Make sure that runs. Okay, this is what we get, right? So our total inventory value by product looks like this, okay? Right, based on the numbers that we have, this is what we're dealing with, all right? And again, this is a computed value. Why? This is a computed value because all we need to compute the numbers that go into the query in each record are available in each row of the products table, okay? They're available in each row, all right? So because we just need to combine the ones that match and get that number, that's why this works, okay? So just to emphasize, right, we have unit price here, 1 unit price, 1 unit in stock, that times that will give us the number that we want, okay? Cool. All right, cool. So again, this sort of thing happens quite often. You can imagine taking this, doing other stuff, like what about back orders, like products, let's say units, units in stock, units on order, right? Units on order, right, minus the number of units in stock, right? And let's call this our back orders. Okay, right, we can order it by that as well. Simply enough. We'll do it descending so we can see the most. What do we get? Make sure it runs. We get something here, right? Obviously, the 0 is perfectly matched in terms of inventory. These negatives don't really make sense. They're not on back order per se. So it would probably make more sense to throw in a condition where we say where that expression is strictly greater than 0. And now we can see those are our back orders, all right? Those are our back orders. And again, all this is done with the computed values, okay? So this is a good example of using computed values, right? We're creating one here, we're calling it back orders, and we're using it in the condition and also in the order by, okay? Right there. All right, cool. So what's the difference with aggregation? All right, so let's introduce a little bit of aggregation here. Right, maybe I'll save this query as back orders. Okay. So a little bit of aggregation, all right? The main idea here is it is exactly what it sounds like. It is aggregating values over a table, right? Over records that meet some conditions, essentially. So let's fire up a new query. And let's say the following, all right? What if I just want to see how many customers do we have in our database, all right? Or let's stick with products. How many products? Select, okay, something, I don't know what. It's definitely going to come from products though, right? Right. Now, what are we selecting here? I don't know. If I want to know how many products I have in total, well, one thing I could do is, essentially just count the number of rows in my products table, yeah? Okay, so why don't we do that, right? How would you do it? There's a function called count, okay? It's good. It's good to know that this function exists. You're going to need it for a number of things you do with the homework and on the exams and other places. It's a very common function. So if I want to count the number of rows, all right, count actually works by counting the number of non-null records, okay? And in that case, I mean, a primary key is always not null, right? You can't have a null value for primary key. That wouldn't make any sense. And so primary keys are always a good candidate to put into aggregate functions when possible, okay? For example, count, okay? So if I count on the product ID, I will just get a count of the number of non-null product IDs, which is really just all the rows that I have, okay? And, right, maybe we'll do this as, we'll just call it total products, right? What do you think we're going to get here? Huh. Surprised? I don't know. Sometimes people are generally surprised at this in the beginning, okay? Myself included. Right? This is not maybe what you'd expect at first, but a little bit of thinking further, and it becomes clear that what's going on here is obviously we're aggregating a certain kind of datum, a certain kind of metric on the products table, okay? So what we've done, we've used an aggregate function, count, to obtain a certain piece of information over all of the information in the products table, okay? And that is what makes this an aggregate function, all right? So when you run aggregate functions, and you can see here we're not doing any grouping, okay? Grouping is critically important. We're about to get to that. And when you don't group by anything, right, you essentially aggregate over the entire table, okay? You aggregate over everything here, and what do you get? Boom, you get exactly one number, all right? You get exactly one number. Okay, cool. So that's the smallest, the most minimal possible example. There's a number of different, variants of this kind of example, like, what is the, I don't know, just the total, I don't even know what you'd call this, some sort of, who knows, total blah, right? But just to give an instance of something else you could do here in this exact table, right? The sum is another function, right? The sum of, say, the unit price, okay? It's not really total revenue, it's not really total anything, but it's something, okay? And if we do that, we run it, we get, okay, we just get some number, right? But the point is you can aggregate on a different function. It works similarly. Maybe the units in stock would make sense, okay? If we throw down units in stock and unit price, right, we might get something like total value, right? Total inventory value, total value on order, something like that. And we're essentially taking a quantity, right? For each one we have this, and we want to add up the whole thing at the end. Okay, and you can see we have, $1 million. All right. So, it makes more sense. Okay. So, these are the kind of values that you get when you're aggregating on something without needing to group by anything. Okay. Generally speaking, aggregating over only one table, you don't need a group by, because you're aggregating over that entire table, right? When there's only one table in the from, right? Whenever you're selecting from multiple tables, usually you're enforcing relationship constraints, and you're going to need to start to group by the appropriate attributes, okay? So let's see what that's about, all right? So we'll go ahead and just kill all this, and let's start over, okay? What I want to look at here first, let's say just the products that have been ordered the most number of times, okay? So all I want to do is I want to just show all the products we have, and I want to order them by the total number of times each product has been ordered, Okay, how would you do that? Well, select, right? Select what? Select first. Obviously, let's just take out the product name, right? We want to see what we're doing. And now there's going to be some expression here, okay? And obviously we know we're going to need products is P right here. Okay? And eventually we're going to need a semicolon somewhere. So just throw that in. All right. Now, how exactly would we go about computing or figuring out how many times a given product has been ordered? So let's say you know what the product is. I give you this product ID. How many times has it been ordered? Right? Well, if you look around, I mean, there's no value anywhere in the database that specifically stores that. So we need to compute it somehow. Okay, how could you do it? Right, it may take a little bit of thinking. Hopefully you build an intuition about this after some time, right? But one tactic, for example, to get this piece of information we're looking for would be to just count the number of rows in the order details table where that product ID appears. Yeah? All right, so put differently, if you think about this as a one-to-many relationship, right? Where the many means, it's many, meaning for every different product, we don't know what that number is, but it's bigger than one generally, okay? But the number we're looking for is exactly that number for every product, right? So if, product 0001 has 10 different orders that it features in, we want to know the 10, right? Product 10 has 100, we want to know the 100, and so on, okay? So to count the number of times this features here, right, we can use the count function, right? Count. But this is a little different. You can see already that I am using the modifier for the product ID, or the full delimiter here with that, right? We'll do this as total times ordered, right? Total times ordered. Okay, we're going to select this also from order details. Right, as OD, okay, and obviously we need to include relationship constraints here, right, being where the product ID in the products table is equal to that of the orders table. Right. Ah, there's an error here, right? Yeah, I know you guys can't see this, right? Unfortunately, it says it's a really important error. I wish you could see it. I'm going to read it out loud just to emphasize, but it says your query does not include the specified expression product name as part of an aggregate function. So now we get to see what you must do when you're using aggregate functions, okay, and especially, right, when you're selecting outside of them, right? You have to tell Access how you're going to do this, right? What Access wants to do without this is it wants to return just one number, right? It wants to go through order details and give back one number here, okay? Doesn't quite make sense though, does it, right? We want one number for every product, all right? And that's kind of the key to how you group by this, right? So what do? Group by P dot product name, all right? You want to group by everything outside of the aggregate, all right? Everything outside of the aggregation function. What do we get now? We get this, okay? We get this, all right? Probably it would be good also to order by maybe that expression again, right? And again, we can't use the modifier for that. We are going to need to use the actual value. Okay, and let's do that descending because it makes sense to see the most. Okay. So we're seeing products just in order of how many times they've been ordered. Okay, how many times they've been ordered. So that's what we're looking at here. And okay, the important thing to notice, I think, is what comes up a lot is how do you know what to group by? What do you put in the group by? Sometimes I'll say you need to put everything outside of the aggregate. Okay, that's all well and good, but what does it mean? I mean, why are we doing this? Okay, so how do we understand that? Well, look at this query, okay? And now take a look over here in products, right? Now, what do we see? Well, the thing is, in products we see for every product, for each product, there's one product name, right? Same thing here, right? one product name in every record here, right? And we get this one number, total of times ordered, right? Now this total times ordered business, we know, came from actually doing a certain function over all of the records of the order details table, right? We looked through all of the orders in here, okay? And we grabbed, for each different product ID, like here is 14, and we said, all right, 1, and then going through, looking for, there's another 14, okay, that's 2, and so on, right? So we did this, I thought I saw another 3 maybe. In any case, 3, all right, and there's a 4th one, okay? It goes through for each one of these, right, and computes that number, right? So that's what's going on, is that it needs to get one number for every product, and therefore you group by product, okay? In this case, only product name, because that's the only thing we're selecting outside of the aggregate from the products table, but that's the concept, okay? Whatever you only want one number for, you group by that, all right? You group by that. Okay. So that's one example, right? And it shows us kind of the general order here, all right? Select from where, group by, and then there's one other piece, which is essentially like a where clause for the group by. It's called having. It would go in between group by and order, right? Finish with order, end with a semicolon. That's your structure, okay? Let me just go ahead and save this. I'll save this as total total times ordered. All right, cool. Now, you might be looking at this, for example, at this table, and realizing or wondering, why do we look at the number of times ordered just counting out the product IDs, okay? Doesn't it matter that, this is only ordered once, whereas this is ordered 10 times, whereas this is ordered 25 times, and so on? How do we get the actual kind of number of times that a product was actually moved, or shipped off? Put differently, how many times was it ordered, but in total quantities, right? Right. Essentially using this piece of information here, okay, the quantity attribute. Right. Well, certainly a good thing to do, first off, and the right way to think about it, though, well, anyway, we should take a look, okay? There may be some subtlety to how we need to approach this, all right? Now, kind of naively, let me go ahead and fire up the one we had before. What we might want to do is think about trying to just modify this and say, okay, well, why don't we just take order details dot quantity and then multiply it by the count, right? So that would be kind of taking, let's take a look, all of those values that we got before and just saying, okay, yeah, 4, but times the quantity, right? And maybe that gives it away why it's not a good idea, right? Breaking this down, right, for laser printer here, right, which I don't remember what that one is. I happen to remember floppy disks is product 14, okay? So floppy disks ordered 4 times, right? Here's a 14, okay, quantity. So let's multiply by that quantity, yeah? But, again, here's product 14 again, and it features with 10. So, how does Access know which quantity to multiply by which number, right? And therein we kind of see the problem with this approach, okay? We're starting to understand or run right headfirst into why aggregating on this isn't going to work, okay? So if we run that, we actually get an error. Access tells us it's not part of the aggregate. And if we aren't thinking clearly, we would just, or if we're going off the knee-jerk kind of stimulus response reaction, we'd say, all right, I got to group by everything outside the aggregate, so that includes this. So, boom, let's do it. All right, yeah, it ran, it makes sense. Oh, the ordering's messed up, so let me fix that. All I need to do is change this to be, actually, I'll have it, right? So all I need to do is drop that in, boom, perfect, I did it. Next, right? Right, so, looks right. How do you know it's not right? It's really tough to say. right? You got to look at it. Start looking at it for a second. What do you see? Floppy disks. Floppy disks? Huh. So this appears more than once, and in fact, we get to see this repetition here, and it starts to, maybe dawn on us that we're not getting exactly what we're looking for, which is for, each product appearing only once with the total number of times ordered over here, right? That total quantity thing. What we're getting is instead a kind of repetition, little combination. What is that from? It's really a product of the fact that when we group by this, okay, what Access does is it treats every combination of product name and quantity uniquely, okay? So it would only take an exact replica of the same exact product name and the same exact quantity, all right, and aggregate those and count them, okay? So for something that it happens only once, it counts it only once, it multiplies by the quantities though, and we just end up with these values that are essentially repeating. It's just showing us the quantities of each one, all right? So this approach is not really panning out. You can start to even try to make this work in other more complicated ways by using something else, but that's, ultimately it's a problematic approach, okay? So let's try to return this back to normal, or where we left it before. Let's make sure we did that right. Okay. Save it. Now let's take a different tactic and simply realize that in the order details table, okay, what we have is in every row here we have one product and one quantity, right? So if we just simply added up all the quantities for each product ID that matches, we kind of get the number we're looking for, all right? How do you do that? With the sum function, of course, right? So let's do it similarly, product name, and now we will use a sum function, right, and just sum on the quantity, right? Total orders, say, right, from P and order details as OD. Okay? Let's then enforce our conditions, right? Where P dot product ID is equal to OD dot product ID. Okay? And grouping appropriately by the product, right? Outside of the aggregate, product name, okay? Ordering by exactly our expression, this sum, all right? This sum. Into the semicolons, check to make sure we got it right, nothing's misspelled. Okay, it worked. It's not exactly the ordering I want it in reverse. And I get this. All right, cool. First thing to notice, obviously, right, is that this is entirely different. Totally different from what we had before. Right? So it was a good intuition to try to check it out and compare like these different compositions here, okay? So some items are ordered many times, some items are ordered in large quantities, so maybe a few times, but ordered a large number at once. Okay, right. You can see there's a little bit of similarity here in all of this. But for example, laser printers are ordered probably 4 times, but only one at a time. Okay, so in total, that comes out to 4, and that's it. That's it. Okay. So cool, right? So we did a little bit of this. We looked at 2 different ways here. We can see how just using the different functions gives us vastly different results, right? Different results. Good stuff, all right? A little bit more to the point, actually, right? Just along these same lines, all right, is not looking at total times ordered or total quantity ordered, but really the big sellers, right? Who are the money makers? Which ones actually bring in the most revenues, okay? So it's very closely related to this, right? And it combines essentially computed values along with the aggregate values. All right. So let's first save this. We'll save query one as, let's just say, total orders. Okay, we'll make a new query, open her up, and right, trying to get more space in here. Let's see if we can do this nicely. Okay, again, we said it's very similar in a sense. Okay, what we want to see are the money makers, the biggest revenues. Okay, so it's related in a sense to the total orders, right? Obviously, the ones that are ordered more often are more likely to be up there because of prices, right? But the issue really comes in with this, right? What if, right, this Pentium here is very expensive, thousands of dollars, selling 3 of them generates $3,000 or more or whatever, right? And if these are $1, right, that's only $42. So let's look at these essentially weighted on price, okay? Weighted on price. And the key insight to realize here and how to do this is that the unit price for every product is already here, okay? We're grouping by product in this query, which means that everything we see in the query output is just for one product, all right? So what do we want to do? Perhaps it's obvious, but let's go ahead and drop this in and just take the unit price, multiply it by that quantity, okay? But then don't forget to group also by that unit price, okay? It's outside of the aggregate in this sense. And we should also just put that right in here to order by that. And see what we get with this. Oh, we're going to change our total orders to total revenues, right? It's revenue by product, right? Bam, and we get this, okay? So this is, yet again, completely different from all the others, all right? And so we can see that when weighted appropriately by price, for example, it changes fundamentally, okay? So this is taking various slices of the data here and combining them in various ways, okay? That each one gives a different picture of what we're looking at, okay? And depending on what it is you're looking for, you want one or more of these, but it's important to realize that you really want to be able to slice and dice data in various ways and then compare differences, okay? And so, just something to keep in mind, all right? Importantly, however, right, with this query here, this total revenues query, which I'll save as that, we actually use aggregation, all right? And so we're grouping by all the product stuff, right? We're summing over something that is in the order details table, right? And so we're essentially grouping by everything else in our select that's outside of the aggregate and essentially is also outside of this table, right? It all falls into the other table, okay? These are usually the most appropriate kinds of grouping structure that you're going to see, all right? And this involves a lot. It has all the moving parts here. However, for example, there's one other piece that we need to throw in to the whole group by mix, okay? Just taking a look at this data, what we see is that, right, essentially the actual computers bring in the largest percentage of the revenue, right, by far. And so that's all well and good. But the prices of these are probably pretty large, right? So they're not ordered very often. We don't see them over here, okay? But they appear at the top of this. So what about, those products that have a relatively low price, okay? Relatively low price, but in fact are featuring here high in revenues, right? Which means that they have a good, kind of orders to price ratio, right? In some sense, they get a pretty good bang for the buck both in terms of their price point, so people order them a significant number of times, but they're expensive enough to kind of feature, add to total revenues in a dense way. Okay, how would you do that? I don't know. Right, we're constructing a situation here, but what I want to throw in is when you need to do something like that, okay, you actually need to now, let's say you only want to look at the middle range of those total revenues, okay, and kind of see something about that. What would you do? Well, right, you could always throw something in to the where, try to put in some conditions on, this and that. But suppose you want to try to put these conditions on the actual total revenue itself, okay? What would you do? Well, let's try and throw it into here, right, just as before, and, okay, and what? And, right, this total revenue business is, let's say, less than 1,000. What happens? We get an error, right? You cannot have an aggregate function in the where clause. That's exactly what the error says. Why did this happen? Because you can't have an aggregate function in the where clause. Instead, what you need is the having clause, okay? Having is like the where clause for grouping, all right? That's it. That's it. So you are going to do this grouping, and then within each group, you're going to apply some condition, okay? Within each group, you'll apply some condition, like that this should be maybe less than 1,000. And you get that, all right? The point here is that this is one of the most common errors, okay? The most common error is not understanding that whenever a condition of any kind involves the aggregate function, involves what you're doing here with the aggregate, you need to put it in this having statement, okay? Having, it's really simple. It's just where, it's just the where for the group by. So they go together, right? But this is the same concept as this. You just get conditions, just conditions, okay? But again, we don't need to do this. Right? What if I wanted to check out that density and all that stuff like I was speaking about before? Well, you could say where the count, right, of let's just do product ID, okay, is let's say greater than 2, okay? And you get this, all right? You get this, right? And you can, again, if you break this down, what you're seeing is those items that were ordered more than 2 times, right? Because just as before, when we had the total times ordered, we used the count function, right? Okay? So we're using it again, right? Even though we're not selecting on it at all. So it doesn't feature in our select anywhere, right? But we can still use it here in the having. Why? Because it has the same grouping structure as the sum that we're using here. Okay? So we throw it into here, and we can use that as a condition, right? So now if I said, if I want to see total revenues, or I want to see all the products in order of total revenue, right? But only those products that have been ordered more than twice, right? This would give you that. This would give you that, right? It's probably, it's not the only way to do it, but it's certainly, almost surely the least complicated way to do this, right? Without chaining multiple queries together or something, okay? And the point here again is that it follows the same pattern as before, right? We had this in the last video when we see that you can make conditions in the where clause on any of the attributes in these tables, even if you don't select on them, okay? And it works similarly here, all right? You can put conditions in having on any aggregate function that has the same grouping structure, all right, whether or not it's in the select, right? Whether or not it's in the select. And we get something like this, okay? Now, for your homework, all right, homework 8, this represents essentially the entirety of what you would need to do on that homework, all right? It has all the pieces here, okay? It's using the sum function, using the count function, which are largely something used very commonly in this course and elsewhere. It has every clause in here, all right, for the full query, right? Select, from, where, group by, having, order by, all right? So that's what you need. I hope this video is helpful, and certainly hope that the quality of these starts to improve over time. Please, again, post in the comments. Let me know how this is going, if this is helpful, how it's helpful, how it isn't helpful, how you think it could be better, and I'm trying to get on this. I think it's again certainly a great medium for us in terms of efficiency, right? Trying to get these concepts out. Okay. If you have questions on this stuff, hit me up on Slack, and we'll get on this quickly. All right. Good luck with homework 8, and till next time.